Okay, so we're going to learn a little bit about Android Things tonight and some robots. And I think this is going to be really fun. I mean, lots and lots of gadgets up here. It's going to be very interactive. So I'm going to ask people to come up here and actually do things. I don't want to push the buttons anymore. I've shocked myself enough. So it's your guys' turn. So just a few questions so I can understand, the audience. Who is new to building Android applications? Okay, perfect. Who is new to building things with electronics? Perfect. Who has heard of the devices like a Raspberry Pi or an Arduino or?
Has heard of?
Yeah. Okay, perfect. That's what I need to know. So here's how tonight's going to go, and I'm going to try to move fast just because there's a lot of stuff here, and I think we're going to have some fun. But talk about what I'm hoping to achieve tonight. We'll go over, do an overview of what Android Things is. Then we'll get to the fun stuff of the actual live demos. Talk about how you can start doing some robotics with Android, and then we'll talk about what the current limitations of it are, and then I've got a bunch of resources. So any code that I have tonight, I'm going to share on GitHub. I'll share a link to the slides up on the meetup site. So don't feel like you have to take notes or follow along because it's all going to be published. So the goals tonight, everyone learns. This includes me. I am not a electronics person by trade. I'm definitely a hardcore software person. I've gotten very good at shocking myself and burning up circuit boards. So if you see something that I'm doing wrong or could be doing better or am misrepresenting something, definitely let me know afterwards so I can make this better. Likewise, I'm hoping that everyone here learns something new too. It's very easy to think, as a software person, oh, I know, I've been doing software for 10 years. Hardware is just, it's out of the realm of possibility. And I even had that mental break or that mental block, and it's not true. So I'm hoping that we can get over that today. I want everyone to leave more confident that they can tackle their first projects with electronics and Android. It's a lot easier to get going than I had anticipated. They've done a really good job with the platform, and there's a lot of really good resources to kind of continue with after this. And then excitement. I've spent a lot of late nights, later than I should have, playing with these things lately, just because it's been a lot of fun. So I'm hoping that everyone here leaves with that same excitement too. To kind of demonstrate that, this was a picture of my clean desk back in December, and they announced Android Things back in December. I was like, okay, yeah, I'll tinker with that, and I'll get a Raspberry Pi. And, the only other thing I had on there was like a VR headset, and it was all clean, and my wife was happy and proud. And then this was it a few weeks ago. So be forewarned, it can be kind of addictive, once you get into it, especially if you've never done it before. So yeah, you've been warned. So let's talk a little bit about what Android Things is. At its core, it's a slimmed down version of Android intended to run on system-on-chip devices. Those means like a Raspberry Pi. So they also support some Intel boards and some NXP boards. But ultimately, those are the prototype boards, and then a device manufacturer would go and take those and build out something custom. And what they get out of that is, they get Android, which is kind of tried and true and tested, that they can run on their stuff. It's not designed for microcontrollers, so like an Arduino will run one app, and it just kind of loops and does that over and over. A Raspberry Pi is a full operating system on a board, and Android is an operating system. One of the things that's unique about Android Things versus just regular Android is that displays are optional. The Raspberry Pis that I'm using tonight that are mounted in the back of these displays don't have to be connected to anything. That's typically different than the way most people write Android's apps. As such, if you're requesting permissions, and in the newer versions of Android, you'll see, hey, I want to use your camera, and you've got to prompt them with, like, hey, can this app do this? By default, when you install an Android Things app, all your permissions are granted. It also means that you don't get notifications up top. So if you're used to using an Android phone and you swipe down all the time because there's always something going on, you don't have that type of user interaction. So it's more, think about the core of what you would build inside of an app, and that's what you get. You also get most of the Google Play services, so all the really cool things that are proprietary that really make Android powerful. They give you in here. Things that require user input or user authentication, because with it being headless or without a display, you might not be able to get that. Those aren't available. And then what it adds to regular Android is a bunch of low-level APIs that you can use for hardware integration, and that's where we're going to spend a lot of our time tonight. That's the fun stuff. So why would someone be interested in this? Because you can already run other operating systems on a Raspberry Pi and other devices, and you can do, they've embedded devices have been around for a really long time. So why is this different? So the first line, Google's pitch is they want you to build connected devices for a wide variety of consumer, retail, and industrial applications, which means they just want you to throw their stuff at all the hardware you can. The business case for it is that if you're a device maker, you don't have to worry about an operating system. You get Android, which is running on some phones. So you can, you've got some level of confidence that it's going to work. You can prototype your products on production-grade hardware. I mean, everyone can get a hold of a Raspberry Pi. And device manufacturers know how to take a Raspberry Pi and turn that into a production quality, minimized, designed for your form factor product solution. That can run Android. Device makers get access to the existing Android developer community, and there's a lot of us. So instead of trying to find some specialized skill that with an embedded software developer, you've got a larger pool of resources available to you. And as a developer, we get to use all of the fantastic Android APIs, tools, libraries, all the goodies that we like to use on our day-to-day life. So those are all available to us too, and we'll see some of that today. So let's do the fun stuff. So assuming you start with a new project in Android Studio, and we'll come to this in a second, the first thing you need to do is add in a dependency to pull in the Peripheral IO SDK, the thing that lets you access all the low-level library stuff. And it's literally one line that you have to add to your file. You'll notice that it still says it's a developer preview. So things occasionally don't work, things occasionally break. So you're looking at kind of what's coming down the pipe. It's building it like a regular Android app. You've got a manifest file too. You need to make sure that you include that this application that you're running depends on the Android Things library being provided to you. And if we go back a screen, you'll notice that normally, in an Android project, this will be listed as a compile scope. This is provided. It means that when the application is running, it doesn't have to go through and package all this other stuff with it. It'll be there for you. You still have activities, and if you've never done Android development before, an activity is kind of like an entry point into your application. Typically it's a screen, but in this case, we don't have screens. So they've kind of gotten rid of that concept, but you still use all the existing activity APIs that you're used to. For the purposes of development, you still want to make sure that you've got an intent filter that will launch your application from Android Studio. If you didn't have this, things get really slow during development. So, whenever you create a new activity, or new application, you'll have an activity with this in it. Leave it there. This one is new. So because you might not have a user interface, and whenever someone turns on your device, you want them to start up your application, you have to have this intent filter, so that way when the device turns on, it can pick, it knows which application it should be starting up in kind of that default mode. I don't know what happens if you have multiple applications installed that have this intent filter. It will probably change. So as long as you're doing local development, you'll need this in there. As far as your activity, and this is basically what you would get if you generated a new screen in Android Studio. So public class main activity extends activity. It'll normally give you a method like set content view or something like that. You don't have to have that. That's entirely optional depending on what you're doing. This guy is the fun one, this Peripheral Manager service. And we'll dig into him some more. One of the things you need to make sure you're doing is that if you start up an application and you start accessing hardware resources, that you need to clean those up at the end too. If you don't do that, then you end up in a really weird state, and you'll lose several hours one night. Not bitter at all. Okay, so what is this Peripheral IO API? So there's a handful of different ways that a Raspberry Pi or all these system devices or embedded devices, let you communicate with hardware. You got these things called general purpose IO pins, and they're basically, you can turn things off and turn them on, turn them off. It'll send electricity through it or read electricity that's coming into it, and you can respond to it. Some of those pins are a little more specialized in that they can send out pulses, which are a good way of kind of varying what something is doing or communicating with other things. And then they've got a handful of serial communication things. This universal asynchronous receiver transmitter is if you need to communicate with devices over what you normally see as like a USB device. The integrated circuit, and I learned that recently this is called I2C, not I2C, is a way of connecting with a bunch of wide variety of smaller things. And we'll see a fun demo of that one later. We're not going to cover the serial peripheral interface or the native peripheral I/O. The third one is kind of more specialized for more powerful hardware or more powerful things, and then the last one I think is fairly new from a few weeks ago. So I just haven't had a chance to dig into it. Okay, so time for the fun stuff. So if you've never seen a breadboard before, they're kind of, you can think of it as these vertical rails on the side. Those all line up. So there's two sets of connected pins that go side to side, and the ones in the middle are connected horizontally. So when you look at it the first time, you're like, okay, I see a bunch of pins here, and I don't understand what's going on behind the scenes. That's kind of what's going on behind the scenes. And it'll let you connect different little components, like a light, or these wires, or the resistors, and things like that. So our first demo that we're going to do is we're going to build an app that can turn a light on and off. So let's do that. I need to be up in this other screen. There we go. So this is basically what we saw before. Is that big enough for everyone in the back? You can read that? Okay.
A little bigger would help.
A little bit bigger? Okay. Let me do that real quick. Better? Perfect. Okay. So this is the same code that we had before. And I'm going to cheat because I suck at live coding. We're going to go check out K1 toggle LED. And our code has changed. There we go. So let's go and run this and see what it does, and then we'll walk into it from there. So if you notice, we don't have an Android device connected. I've got my Nexus 6P, and I've got this emulator over here that isn't running. And we're going to connect to this guy. But how do you get to him? If you notice, and we'll see how well this works in this light. It's hard to see. There we go. It'll tell you the IP address of the device when it turns on. So in this case, it's 192.168.1.44. So let's try this. We're going to do ADB connect 192.168.1.44. And now,
That's the IP of the circuit board, breadboard?
yep, that's the IP address of this device running right here. So I don't have any USB cables connected. It's all going over wireless. And that's pretty cool because.
So the breadboard has a Wi-Fi
Yep.
transceiver on it.
Yep, and I went through the process of getting it set up on the Wi-Fi earlier, and their developer site has documentation on how to go through that process. But it's kind of magical that you do this, and now you can run an Android application. So let's hit go. And it'll take a second to run. It's building, building, building. Building longer than it should have. It says it's installing, launching. This should go white in a second. Hey, it works. Okay, so the first person who wants to get shocked. Yep. Okay. So if you look on the screen, and man, this doesn't work out as well. Oh, there we go. So I've got a button that says on and off. What happens when you press the button on the screen?
On the screen?
Yep. Hey, light turned on. So the first time you do this, it kind of feels a little bit like this. So really, when that works at like 12:30 in the morning, and it's exciting. Okay, perfect. So you can sit down. So let's see what it took to make this work. Okay, so we've got a peripheral service. We've got a button on the screen, and I'll skip over that right now just because say give me access to this button. What we're going to do is we're going to open up a GPIO pin, the general purpose IO pin, and in this case, I've got it set plugged into pin 17 on the board. If we go back and look at this, that orange wire is pin 17, and I wonder if this will work. Yep, you can see the thing that says GPIO 17. That's what it's plugged into.
So you've got, from your laptop, you've got a USB that goes to the Raspberry Pi?
Nope, all wireless.
Oh, okay, that's right.
Yep. Okay. So we're opening up, we're getting access to this pin, and we're setting the direction that it's going to send a current out, and it's initially going to not be turned on. We're going to set our toggle button to be the state of the pin. In this case, it's going to be off, so it's not, our toggle button is going to be set to off. And that whenever someone changes the state of this button, we're going to set the value of the pin to be with that button. So when you turn it on, the pin should start emitting current, which will turn the light on. And then, like I said, always make sure you clean up your stuff at the end. So what is that? 1, 2, 3, 4 lines of stuff that's actually interesting to turn on a light. Adam?
Say what the LED toggle was, like the ID there. Like
Yeah. So if I go to my layout file, it's just the button I have on the screen that we showed over here.
So for all the pins, you just have that's just a bool value that you set on or off?
Mm-hmm. Yep. When you're sending stuff out, when you're sending current out, it'll either be on or off, at least for now. And by default, it's type will be actively high. There's other things you can do with that too, but it took 4 lines of code to turn on an LED. That's pretty exciting. Okay, so let's do something else. Okay, so we saw Tom Hanks. There we go. So let's, yes?
How long does the LED stay on? Is it just till the application ends, or?
Until I unplug it.
Okay.
Yeah, they don't take up much power at all, so they would, if you just had it on a battery, it would last a long time. Okay, so our next thing, we're going to read stuff in off the pin, off these GPIO pins. So I've got a physical button over here. We're going to press it, and it should turn the light on and off. So if you look over here, we've taken what we had before. We've added a new button in here, a handful of new wires. Why they don't count these pins out in a predictable order, I don't know. We went from 17 to 22, and there's only 1 in between. I don't get it. And we've got another resistor in here. We're going to set our pin up in the code to say we're going to have current coming into it, and that's so we're basically going to put ourselves into a listening mode. We want to be notified when the current goes away. So right now, it's going to, if you look, I've got power coming over here, going up through the resistor, through the button. When the button is unpressed, it's running all the power into this pin that we're listening to. When you press the button, it's going to close the circuit and all the power is going to go to ground. And what we care about is knowing when that current falls off. So our trigger type is going to be when the current goes away. Let's take a look at that. And I'm going to cheat again. Again, all this code is up on GitHub too. So we've got another method down here. We're opening up pin 22, setting our direction to in, saying that we care about when the current goes away. We're setting up a callback object that says, whenever this, the state of this pin changes, let me know and let me know the value, and we'll just update the button, the checkbox we had on the screen before, which will then go through and also update the value of the LED. So we're kind of chaining two things together. We're taking this, callback that we just built up here, and it's, putting it on this pin, so that way, when something happens, we'll know about it. And again, we're going through and cleaning up at the end. We're removing all our callbacks. We're closing out the pins, and so that's what's going on. So who's next? You want to come up here?
Yeah.
Yeah, perfect. So let me. Okay, so if you see, there's a little button right there.
Mm-hmm.
Go ahead and press that. Yep. Let go.
You forgot to.
Oh, yeah, that might help.
Obviously, it wasn't my finger's fault. So.
Received.
Building, 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 installing. We'll see a flash in the second. Yeah, cool. Okay, now let's go look at it again. Yep, so you should be able to press the button and light turns on and off. You press it again. And so let's see if this will work. Okay, and if you keep pressing it, we're also updating the state of the UI on the screen.
Oh, hang on.
So you pressed it twice and it didn't do something
I didn't
right.
press it. Hang on. It's on. The light is on. I press the button. Okay, got it. I double clicked.
Yep,
It is working.
perfect.
So when he presses the button, you're updating the state of the button on the display.
Yep, so when a button,
The button is not
cool.
functional in terms of turning it on and off, is it?
Right, the button updates the state of the toggle button on the screen, and the toggle button, when its state changes, goes through and,
Physical button.
yeah,
Updates the state of the display button.
Yep.
But the display button is non-functional when it comes to the light, right?
now the display button at this point, if I still go through and touch it,
Still works?
yep,
Okay.
The display button is functional.
so this is all kind of making, yeah, Stephanus?
What do you do to take care of the contact balance? I know that's a little advanced topic, but anything in the libraries that take care of that?
The contact bounds,
What do you experience when you collect registers twice?
you would normally put in something to kind of debounce those, so that way it, if it sees 2 or 3 signals all within, 50 milliseconds of each other, it only takes the last one or the first one or something. I got lazy, I didn't put that in there. It seemed to work well enough for my purposes, but yeah, you'd normally have something in there about that. This is all kind of making sense right now? Fun stuff? Cool stuff? Cool.
Good to have a hardware guy who knows about debouncing.
Yep. Debouncing you can do in software, which is, now we're in my space. Okay, so next thing, we've got another LED down here. We're going to control the brightness of it. So what we use for this, and if we go back to the screen before, we talked about this pulse width modulation. The way I like to think about that one is, right now the lights in the ceiling are on. If I turned them off, the room would go dark. Now imagine my fingers being able to do this really quickly. If I did it quick enough, I could kind of make the room look dim. And this is kind of how we're going to do it. So what it does is it sends out a pulses of electricity. You can say, send it out continuously, basically a full load, and it's basically what we have in here. Or I can say, send it off half the time, and it'll go through and it'll make the room look dim. And we can control the speed of those through software. So the diagram we have up here looks very similar to what we had before. The only difference is that we're running through a different pin. The pins on all these boards are not universally interchangeable. Some of them have very specialized purposes. My Raspberry Pi has one useful PWM capable pin, technically two, but you run into some other things with that, at least on the preview versions. So what we're going to do is, let's do this. Oops, wrong way. I'm going to cheat again. So do git checkout K3 LED brightness. And so I don't forget, let's go and run it. Yep. Okay. So here's what we've got going on. We're going to have our, add this slider to our screen that you can go through, and when it's all the way to the left-hand side, there's going to be 0 power going to it. The light should stay off. When you slide it all the way to the right, the light should turn, incredibly bright. We're using a different method here. Instead of opening the GPIO pin, we're opening a special PWM pin that exposes, or a PWM device that exposes different capabilities. We're going to set the frequency of it to about 120 hertz, which a little over 8 milliseconds. And we're going to turn it on. Don't forget to do this, otherwise you'll lose another few hours one night. We're going to set up a listener on our UI, the sliding bar on our screen, and whenever it changes, we want to set the duty cycle. Basically, am I all the way on? Am I all the way off? Am I partially on to some fraction? And then at the very end, we're going to go through and close out all of our stuff again. So, what is this? 1, 2, 3, 4, 5 interesting lines of code. Is it running? Cool. Okay, who's up next to get shocked? Yep, perfect. Okay, so you'll see a slider on our screen. It says single LED. And as he moves it, let's see if I can find a better angle. Go ahead and slide it all the way back over. You guys kind of see how it's changing its brightness? Pretty cool stuff. So that's useful for wanting to control, the brightness of LEDs. You can also use those as a way of communicating with other things, things that can listen to kind of those clicks. So and we'll see some of that in a little bit. So let's do this. Let's go back over here. So I mentioned before that the Raspberry Pi only has effectively, one useful pin that can do this pulse width modulation. So what do you do when you want to control a light that can, emit light on a red, green, blue spectrum? So a multicolor light. You either buy different hardware, tell your device manufacturer, it's like, hey, send me this prototype board with all these other things on it, or you get creative. We're gonna get creative. So the universal, the USB or universal UART communication style. I can't remember the universal accessory receive transmit. There we go. Is a way that you can communicate with other devices that know how to do serial communication. So I've got an Arduino over here. He's got 3 different pins, one for red, one for green, one for blue. And I've got, it's hard to see on this wall, but this LED that can display lots of different colors. So think one of like the $70 Q bulbs, but made with junk in my basement. It only has 2 pins that we're communicating with the Raspberry Pi. A receive and a transmit. Don't get those backwards, otherwise you'll lose a few more hours. Again, I'm not an electronics guy. And you need to have a shared ground between all the stuff to make them actually communicate and work together. And with the latest version of the Android Things library, depending on if you're doing stuff with Bluetooth and this style of communication, you've got some additional configuration you need to do to the image or the Android operating system when it's booting up to turn things on or off. I'm hoping that gets simplified and goes away, but we'll see. So let's do this. Let's go to, where am I at? Get checkout K4 LED serial. And we're going to go ahead and run this. So while that's doing that, very similar code. So now we're going to have 3 sliders on our screen. One that controls the red channel, one that controls the blue channel, one that controls the green channel. We've got a different type of device we're opening up now, this UART device, and they're all named. And if you ever need to figure out what devices are on your board, you can always do a service.GPIO list, I2C bus list. It'll tell you what's available for you to access. And on my board, there's only one device I can access. It's called UART 0. I've configured this Arduino to listen with a baud rate of 9600 and a certain data size and a parity and stop bits. And I'm not entirely sure what all of this means, but it was required to make it work. The code that's running on Arduino is just really simple C code. It's got one application that runs on here, and it's constantly looping, looking for new stuff. So I've told to listen at 9600 baud. I've got 3 pins I'm listening to on this that are driving the LED, and they're all going to be set to output. So very similar stuff to what we were doing before with the outputs and the pins. And then I'm going to be listening for things to come across this serial bus. And when I do those, I'm going to read 3 numbers out of it. So I'm basically sending over something like 128, 128, 128, and then a new line. And when it gets that new line, it's going to go through and write out all that stuff and control the brightness of this light. So pretty simple stuff. So we've got our same UI listener. We're listening for, and I'm going to register the same one to all 3 sliders. We're going to get the red value, the green value, the blue value, build up our message, red, space, green, space, blue, new line. We're going to turn that into an ASCII byte array, and then we're going to write it to this bus so that the Arduino can listen to it. And then we're going to assign our listeners, and again, making sure we close out our stuff at the end. Is this running now? Cool. So if we look at the UI on our screen, we've got 3 sliders with red, green, and blue. And we've got this thing powered on, and he's going to control this light down here. Okay, who wants to come get shocked? Ben? Perfect. So I'll let you go ahead and move those things around. Oh, so you're moving to red. I think you're moving to green. Moving to blue. That's a really bright light. Can everyone in the back kind of see this thing lighting up and changing colors? And so whenever he's changing this, we're going through and reading the values off the sliders and sending those to the Arduino, which is then pumping out stuff to the pins on it. The same, pulse width modulation pins that it has to control the color of that LED.
What's the top slider?
The top slider is what we had before. It controls the brightness of the LED that we had before. So these are all building upon each other. Okay, so that's all fun. I'm going to turn it off because that's really bright in my eyes. So again, what is this? Just a handful of lines of code. This one has a little bit more to get the data, the communication stuff set up. But and the documentation on all of this is fantastic.
So for the Arduino thing, did you use the Arduino IDE to write that little thing?
Yeah, I used the question was, what did I use to write this little program that's running on the Arduino? Yeah, I used their IDE. So this is just C code that reads a lot like everything else we write.
Your code that writes that converts to a byte array, can you show that again?
Yeah.
So that uses a char set of ASCII.
Yep.
On the other end, you're looking for parse ins.
Yep. So I'm basically saying, take this, take the.
ASCII's a say 8-bit code, the parse int, wouldn't that be 16-bit? How's that work?
can't remember the bit size that's going across the wire, but their library, I can't remember the bit size that's going across the wire, but I know that their library obviously is doing a good job of being able to parse this out. So it's looking for, you know, something, a space, and then reading that in.
Probably limiting the bit size, data size after your baud rate line, just
Okay.
What do you say? I couldn't hear.
Jeremy said that it's probably limiting the you know, bit size that's going across the wire, the byte size to that, to the 8. I'd have to look into the documentation to know one way or the other.
Okay.
You pull up the other code again, real quick.
What are you looking for in here?
Okay, cool. Just the loop at the bottom.
Yep. Yeah, so this is the same structure that every Arduino app is going to have. They're going to have a setup method, and then this thing just spins. So even as it's sitting here, you know, cool to the touch, it's just spinning on this.
See, to me, that parse int means it's looking for 16 bits for an int, and so that would be 2 ASCII characters.
Not sure.
Yeah, okay.
I'd have to look at the documentation to see what they're doing. Okay, so we have a problem. Our Raspberry Pi effectively had 1 or 2, you know, pulse width modulation pins, depending on how you count it, and I want to control a lot of different things. My Arduino has 6, and that'll get me a little bit farther, but still not terribly far. This is where we start doing things with the I2C bus. This, so if you notice, I didn't bring it out, okay. There's a little board over here that looks a lot like this one. They're all connected to this Raspberry Pi. And we're going to control a servo. So a servo is like a little motor that knows how to listen to these clicks. So if your clicks are like 1.5 milliseconds, it can translate that into a physical angle. If you're clicking for 2.5 milliseconds, it can translate that into another physical angle. And as you vary that, things go back and forth. We'll look at some more code for this in just a second, in different ways, but that's what's going on. And I've got a demo of that over here, and we'll look at it here. The interesting thing about this way of communicating with things over a serial bus is lots of these little breakout boards that are, you know, really have specialized purposes, you know, support this method of communication, and you can chain them all together to do a lot of really powerful and interesting things. So this board up here that I have that control up to 16 servos, you can chain 62 of those together with unique addressing, which will let you control 992 servos. I don't have a demo of 992 servos. That would, I do have a demo of 16 servos. So this is my basement a few weeks ago, or a few months ago or whatever. And I've got the same type of thing on our screen. We've got a slider, and as you move it one way, all these servo arms move one way. As you slide it back, they all go back the other way.
You did this one.
Yep. And you can kind of see them all moving down at the bottom. Pretty fun, cool stuff. And you can see like this mess of wires that's all going in here, and it's, yeah, it's cool. The range of motion will depend on the servo. All the ones I have are 180 degrees. Effectively a little bit less than that, but.
Could you write an algorithm to control the speed and how much those turn out?
The question was, can I write an algorithm to control the speed of the servos? So without that, they will go to one place to the other as fast as they physically can. Being able to control it would be nice. I'm going to get to that in a second. So you can have a bunch of different types of devices on the same bus. So in this case, this demo I've got over here, this little board that I showed up on the screen is going to control the servo. This is another bus, another device running on this I2C bus that's taking these readings of these sensors. So as you press them, when they're unpressed, they basically translate an unpressed state into a 0. And when you squeeze them as hard as you can, it'll turn that into like a value of 2000. And then you can respond to that. This is an analog to digital conversion. So let's see if this is still working. Okay, so for this one, I need 2 people. Who wants to come up? Jason?
You have I'm the
Yep.
victim.
Where should I stand?
Okay, so you see these little green discs over here?
Um,
I mean,
yes, I do.
Are you gonna try to figure out who's stronger? Because I want to lose.
we're going to figure out who's stronger. Okay, so these things up here are force resistors or force sensors. So as you squeeze them, they return one value. As you let them go, they all go back to 0. And we're going to respond on that. So I'm going to do this. I'm going to try to put the camera. Perfect. Go ahead and hit start on the screen. Just doing a countdown. 5, 4, 3, 2, 1. Now, Jason, go ahead and pick one of those and squeeze it as hard as you can. Ah, they missed the bell.
missed it.
Yeah. Go ahead and hit reset, restart.
Play again.
Yep. Yep. So go ahead and hit start. And I'll let you.
Hit start, you squeeze.
So you can turn this into kind of a fun game, and I'll leave all this stuff plugged in so you can play with it later. But so we're taking the values of these sensors, turning that into some numeric value. Whenever Jason gets to 100%, I'm going to tell the servo, go ahead and swing your arm and ding the bell. It's completely impractical, but fun. Oh, and I can show you the code for that. Force game. Where is it? Open, reset. Okay, so I don't know where it went. But the code is up on GitHub, so if you're interested in seeing it later, I can kind of walk you through it. But again, it's just a handful of lines of code. When you're doing things with these other devices, like this, the thing that's controlling the servo, and the thing that's reading the sensors or the values of these sensors, you typically have some type of driver interface that lives around these that knows how to interpret all the bits to send back and forth. To do that, you end up going and looking at the fact sheet for these things, which are like these 50-page plus documents that will put you to sleep faster than any book I've ever read. And they're like, okay, make sure to put this bit here, and this bit here, and this bit here, and this bit here, and invert this one depending on the state, and this stuff. If you're going to go through that process, the company that you end up buying these boards from usually have drivers already. They'll either be in C or Python. I took mine, copied what they had, and ported it to run on Java. It took an hour and a half or so per thing, some trial and error. It's pretty straightforward. Lots of magic numbers in that code which I don't like, and then you kind of go. It's like, how did they get this value from the fact sheet? And it's a big discussion all itself. But if you're doing things like that, you might have to go through and port these drivers over, or work through something like the serial bus. Let the Arduino control those and interact with that directly, whichever one works best for you. They also have this new native I/O, native Peripheral IO API. I don't know how portable that is for some of these libraries, but so fun stuff so far. Yep, cool. Okay. So now we're going to get into the robotics. We're seeing things move. We're being able to respond to things. So how did I get into all this? This has been kind of recent within the last few months, but a little bit of background. You can kind of guess my age. And so imagine what movies I was watching growing up with. RoboCop. You remember the big thing from Aliens? Yeah. Here's the granddaddy. This ATST from Star Wars. Watching this thing walk through the door, I'm like, man, I'd love to have one of these. Okay, so that's been with me for 30-some years now. More recently, so this is a picture of my daughter. She's going to be going into kindergarten, and she's been ultimately insanely curious about all the things we're doing downstairs. So this is her basically wiring up, putting things in the right places with all the right pins for kind of that first demo that we had of, here's a button on a screen, you push it and it turns the light on and off. And This is her doing it. And she did a fantastic job putting it together. So one night back in January, I'm putting her to bed, and we've got this book called Boy and Bot, and it's a cute kid's book. So we've reread it, and at the end, she said, Daddy, can you help me build a robot?
She asked
So,
that? Your daughter asked you that?
Yeah, she asked me that. This is after we finished reading this robot book. So imagine my excitement. I'm like, hell yes. Said, yeah, absolutely, but it's 8 o'clock at night. You need to get some sleep. I need to get some sleep. I didn't get sleep. Said, okay. But so she says this, and it kind of catches me off guard. It's I want to build a mean robot. What? There's already lots of nice robots, like the one in the book we just read, the one in, like Big Hero 6. She's lots of robots. But she really wants to build a mean robot. I said, no, we're going to build a nice robot. This is a legit conversation. So, no, we're not going to make the nice robot mean. We're going to, start with building a nice robot first. I said, okay. So, yeah, it starts off nice. So we've built a robot. So let me turn this on. Let's see. So this will hopefully turn on in just a second. Oh, no. Oh. Okay, so I shouldn't have plugged those in so early. Okay, so demo fail. So imagine this thing kind of wobbling around a little bit. It's running a Raspberry Pi, running Android up top, no display. On the back side of it, controlling lots and lots of servos, all on here, entirely battery powered. I plugged these in earlier, and I seem to have fried one of my boards. I've gotten very good at this. Yeah, no voltage. Okay. Yeah, it's a skill. But I prepared for this. So this is it, walking in our office the other day.
Walking.
Yep. Yeah, walking. So still very much a work in progress.
Walking like people walk out of bars.
Yeah. It's more successful than I've been walking out of bars. So. So it likes to fall over. We're still kind of iterating on that, but this is kind of what you can do with some of the things with Android Things. Longer term, I can put all kinds of sensors on it, like a gyro, an accelerometer, and things so it can detect, hey, am I standing on one foot, and how to balance itself. I apparently need to work out the power issue first, so that's what's going on. So, oops. Go back. So it's Android Things running on a Raspberry Pi, controlling all of these different motors. I've got a companion app that lives over here. Where you can basically tell it to reset, pause yourself, start walking forward, walk backwards, death to humans. No. You can go through and configure and tweak and maintain all the different servos to make it do what you want. So if I wanted to make it, basically lean forward, I go through and drag this. I need to tell it to control it. I would, drag it like this, like we're doing with the LED before, but in this case, it would control that. You can do a little micro maintenance on these, adjustments and default angles and what they should do. Making a robot walk is actually kind of a pain. So, I've got, all the kind of different animations and motion set up. So your question before of, how do you, control the direct or how the speed of this thing? So like on this top one, so this top hip joint, we'll start at the current angle, add 10 to where it's at and return. And kind of do like a linear interpolation over that over 2 seconds. This ended up being insanely useful for prototyping and development because as I'm going through and making little tweaks, they're all getting synced back over to the robot via Firebase. So Firebase is a real-time database you can use. The data structure, let me see if I can pull it up. Go to console, do Firebase. Go to console. Let's see if this works. I'm in the wrong browser window. But it's just a regular database, that not no SQL database. You can put stuff into it, and then everyone who's listening gets updates immediately. So, having watched all those movies before, nothing bad has ever happened in the history of movies when you put a robot on the internet. So, lots of servos, lots of power. Had a voltage regulator that apparently didn't work. All the parts for it were custom 3D designed, which is really cool when your daughter is like looking at something on a screen and in her hand is like, oh, I can make this. Had never been into 3D printing until recently either. That's another fun thing that'll.
So you have a 3D printer at home?
I don't, but I've got a neighbor who's awesome.
Oh,
Yeah. So, can you do robotics with Android? Yes, absolutely. It really does work.
Design 3D printed parts?
Yep. Yeah, all those I've built up in.
What design tools do you use?
I started off in FreeCAD and got frustrated, and then Autodesk has a product called Fusion 360 that is absolutely fantastic and easy to use. So definitely recommend starting there. So can you do robotics with Android? Yes. Can I do powered robotics with Android? That's apparently still a work in progress. What's awesome is that the code that I'm running on the robot and the code that I'm running on my phone, there's a lot of shared code between those. So that's kind of a nice reuse from a business perspective. I can get I can get stuff done faster. And I got to use all of the tools that I'm used to. Android Studio, Dagger for dependency injection. I've got a lot of these things wrapped in RX Java. All of the things that I like pulling into apps to make things easy. They're there. Your question about how do you control the speed of the servo? When you're building Android UIs, the user interfaces, you sometimes want to animate like a button from here to here, and they've got this class called a value animator. It's like, okay, take it from an x of y of this to an x of y of this, and it'll translate it for you, and you can respond to it. That apparently works really well for servos too. So you can say, if I want to go from 0 degrees, which is clicking at 1.5 milliseconds, to 180 degrees, which is 2.5 milliseconds, I just need to transition what I'm sending out to the servo between 1.5 to 2.5. And then it will go at whatever speed I want. Whether if I want to say, do it over 4 seconds, it'll go. And it'll find all the right values in the middle that I can write out to control this. So I don't think that was a use case that their UI team had thought of, but it worked out perfect. And then Firebase actually works really well. It took 5 or 6 lines of code to get it all in there, and listening to things, and then as I'm making updates to the app, they're all getting sent to the robot. 50 milliseconds to a second delay, so real time enough for my needs. With the latest version of Android Things, they've introduced some Bluetooth support. I'll play with that. I might try putting an actual server on the robot that things listen to. We'll see. Lots of fun things you can do with that, though. So, word about safety: don't do what I've done. I have fried lots and lots of circuit boards recently. One last night. So, learn about how power works. If you put batteries, in series together, the voltages add up, and when they add up, then electronics like to go, poof, and you get the burnt silicon smell. The batteries I have on here are these big lithium-ion batteries that have tons and tons of power behind them. They're the same batteries that they put inside of Teslas, I learned recently. So imagine that on this. These are really good for robotics purposes because you can do a lot of stuff with them, and they'll go for a really long time. Make sure that they have some protection circuitry inside of them so that they don't blow up on you. If you want to have a fun night, start looking at 18650 fires on YouTube. Kind of scary. So there's the more you know slide. So what are some current issues with Android Things? Definitely still in developer preview. If you want to use one pin as like an output and then you want to change it to something else later, you have to go through and actually reboot the device to kind of change it in modes. They've got a handful of other issues to it, so it's coming along, but still not 100% polished yet. Getting the device actually on a network for the first time can be a little bit brutal. If you're in a house like mine where you only have things wireless, how do you connect to it initially? You either need to get this really unique serial adapter, or plug it into a wired network and go through and run this command that'll go through and set the IP or set the wireless network for this thing that you can connect to. They've got documentation on all this, but it's still kind of a pain. And that might just be isolated to developers, because when you put this out into the real world, someone else will have a better experience. Okay. It does require more powerful boards. The latest Raspberry Pi is what they support, and I think that's kind of the lowest power board they have. The newer Raspberry Pis, the $10 ones, not enough power to run this. So it's definitely for higher demanding applications. And I mentioned before that a lot of these drivers I had to port over from existing things. That can slow you down until that ecosystem gets in place, or there's other solutions. So just things to be aware of. Some resources. There's the website for the product page that'll give you access to all their hardware information and all their software information. Rebecca Franks is a GDE out of South Africa that has done a lot of really interesting and cool projects with Android Things. Definitely check out what she's doing. And then when you get to the hardware, Adafruit, SparkFun, SoundFounder, they're all really good resources for actually having the hardware, like all the little boards I've bought, and the software to run them. And they've got a really good community around people asking and answering questions. All the code, literally, if it was running up here, it's up on there. So kind of a recap. I learned tonight that I don't have my power issue completely resolved yet. I hope everyone else learned something too. I'm hoping that everyone kind of had some fun, is excited about what's going on here. And we talked about how to interact with some of the hardware. All of that stuff worked, which is really cool. Some robotics, a little bit, and the current issues and some resources. So a few things. I mentioned I have an awesome neighbor who printed off all my parts. Literally, he offered it up and said, and I gave him this STL to go print at 1 in the morning one night, and then the next day the part is like sitting on my front door. So definitely encourage you to find neighbors like that. Stuart had a demo of, where is it? Oh, the robot? Oh, are you moving it? Okay, nope. So it's listening to Firebase too, and also kind of responding to what's going on. So as the robot is moving, this will move too, which is really interesting from being able to visualize what is going on in somewhere else. Press the one key. Yeah, his walks, mine doesn't.
Or you could do that on your phone too, right?
Yep. Yeah, I would be able to kind of control the slider. And then I had a bunch of people that gave some feedback on the presentation, so thank you for all of them. Those are all the ways to contact me, and I'd be happy to answer any questions. And I didn't go over. Cool. Sean?
Yeah, so we got a few folks that are new to IT in general.
Mm-hmm.
And so what are some practical applications that you all see for time doing stuff like this?
Or if maybe it's not immediate, what's the future look like? What would you do?
So this really excites me because I see more and more smart devices coming out, and I don't see as many embedded software developers coming out, but I do see more Android developers coming down the pipe. And when you have an operating system that's running on some billion phones, that's kind of tried and true, and they're saying, hey, we can throw this on your hardware too. That's an interesting business case for me. So what is our next application that we're working on? I don't know. But it's interesting to kind of see what the possibilities are and how to do things with that.
What you looked at the libraries, anything for
So you get all of the security that's baked into Android with updates getting pushed out by Google. So as new things are being discovered, they can give you the latest versions of the operating system with all of that stuff baked in. Beyond that, you're kind of on your own. So it would depend on kind of what you're looking for. So if you need a kind of a hardened, tried and true, trusted operating system that hasn't been mangled by Samsung, this is a good place to start.
Once it's on the Pi, does it like self-update, or do you have to burn a new image onto a flash card?
You currently have to burn a new image.
Okay.
Yep, which takes about 10 minutes, but it's still a developer preview. That's one of the things I would expect to kind of get resolved to take advantage of all the security updates.
And don't they provide any kind of simulator for this?
Nope.
We have to really burn these?
No simulator. You actually have to go out and get hardware. It would be nice. It would, I don't know how you simulate some of the things. Like if you've got things miswired, all you get is like an IO exception. And it's like, okay, is it the hardware? Is it the software? Is it, do I have things misaligned right? Those are things that'd be harder to test out in a simulator. But yes, it would be nice if they had all of that. If you're building a larger scale app, I would probably look at like a dependency injection pattern to kind of isolate you from all of that. So you can kind of mock out and simulate what those inputs and outputs would be.
You said, so it works with the Raspberry Pi, does it also work with Edison?
Yeah, there's the Intel Edison board, their Joule board, and then I think NXP has a few boards that they support now too. The Raspberry Pi is definitely the cheapest. The other ones are definitely more powerful for other use cases.
I thought they did have an Arduino board or something.
It might be one of the Edison boards that's does like that, but
Maybe that's it.
I'm not sure.
How long have you been interested in robotics?
2 or 3 months. Since my daughter said she wanted to really build a robot, I was like, game on. So yeah, definitely still new to it. Experimenting and fun. I've got a handful of sensors at home, like a gyro that I'm going to throw onto this. Taking some of those force sensors and putting them onto here. The software is the easy part for me. Figuring out the physics behind, okay, how do I make this thing not topple over?
So, I know this was being a developer preview and you not being into it, but how reliable is it, like, to plug it in and leave it running for days at a time? I mean, like, for some, I'm just trying to think of application for, like, home automation or something like that. Would Android Things be a viable option, or is it not there yet?
I think it's probably a viable option. It would depend on kind of what you're trying to do.
I mean, just leaving it
I mean,
running.
yeah, as far as the hardware, I mean, there are people who run media servers off of Raspberry Pi, and it seems to work fairly well for them. If you needed something that was industrial grade, I would probably talk to a specialized device manufacturer.
Well, the biggest thing, I have 2 of the original Raspberry Pis that I used to, and that's my only experience with those is really just throwing Rasplex on them and stuff like that. And those weren't that reliable, but that was also when they were first coming out.
Yep. So you won't be able to run Android Things on those devices. It's only going to be the latest version of the Raspberry Pi and then beyond.
Yeah, that makes sense.
To outfit something like a room this size with LED lights that can change color, what other larger scale solutions exist for that in terms of the hardware? Does something like Android, has someone released something like an app in Android that allows the Internet of Things home to adjust your home lighting? How far advanced are commercial applications for this technology?
For Android Things with commercial applications, I would kind of look at it as people are just going to be adopting it. There's nothing out there yet with it being a developer preview. The hardware side of it, it'll depend because you're going to run into that with any platform. How do you control either that many devices? I don't know the right answer to that one. I'd have to go digging, but.
Is this their parallel to HomeKit then, in terms of the home automation front? Obviously, this does a whole lot more at the low level hardware side, but do they have an equivalent for HomeKit home automation?
So is it, I can't remember if it's Brillo or Weave is kind of their data format that they use, that they've defined for interacting with different types of devices. And so these types of things would be emitting those types of, I think it's Weave messages. It says, turn this light on, turn this light off. You can actually, like I've got a bunch of the Philips Hue lights that you can, control the light color and the brightness in my house, and you can connect them up to their, console and, issue the commands like, hey, make this go to this color, and it'll do it. And it's like, okay, well, that's pretty cool. So definitely some overlap. I think they're wanting to get more things into that space and creating a platform that people can build solutions on that fit into there. So I think the HomeKit is it just the messaging, or is it the hardware too?
They're both.
Both? Okay.
You have to be HomeKit certified, which requires particular hardware. You have to go through Apple to get the certification, which
Okay.
requires hardware.
Yep, I don't think that they're that far along on, or I don't know of anything on the roadmap about that type of thing with the certification.
But most devices are compatible with
Yeah. They can speak one language or the other.
Alexa or Google Home.
Yep. Any other questions? Cool. Well, I hope you guys had fun. I'm sorry the robot didn't walk. I'm going to leave the rest of these things turned on. Feel free to come up here and play with it. And again, all the code is up on GitHub. So thanks for coming out.